Hello, so in this video I want to review the idea of determining Lewis structures for diatomic molecules. Diatomic molecules are a little bit, well, simpler or trickier depending on the way you think about this. One thing is, it's kind of hard to Lewis structure these in terms of like dot diagrams. It's kind of hard to put together the right number of dots, so I think that's a tough approach for these structures. An easier approach, in my opinion, is counting up the valence count first, coming up with how many electrons you have in these for 5 plus 6 plus 1, for 12 for NO minus, 5 plus 6 for 11 for NO, and 5 plus 6 minus 1 for NO plus. And then tying these in with what O2 looks like and what N2 looks like, where you have 12 electrons for O2 and 10 electrons for N2. And so for N2, triple bond, there's our 10 electrons. Double bond for oxygen, there's our 10 electrons, or 12 electrons for oxygen. And then likewise for NO minus, it looks similar. So the golden rule, if you will, for diatomics is we have to satisfy, when possible, the octet rules for both atoms. So if we had carbon monoxide, we go with the triple bond here, CO, 4 plus 6 for 10 electrons. So anything with 10 electrons is going to have a triple bond. So NO, triple bond, lone pair on oxygen. Oxygen has to have a plus charge here. Nitrogen stays 0. Now you may think that this is wrong because oxygen has a positive formal charge and nitrogen has 0, where oxygen's more electronegative. However, there's just no other way to satisfy the octet rule for a diatomic molecule with any other arrangement of electrons. And so then likewise for NO, odd count, one of the atoms has to violate the octet rule. So we're like kicking an electron off of NO. So do we kick an electron off of the O or off of the N? And so if we just compare those two possibilities, here's one, or do we go with N double bond O, lone pairs here, lone electron pair on nitrogen, and we're going to go with this one. Why this one? Well, this one has a 0 formal charge on O, a 0 on the other N. The opposite compound has a negative formal charge on N and a plus 1 on the O. So we've maximized, or we have higher formal charges on the left structure. That's worse than having the minimized or lower formal charges. So in general, we choose a Lewis structure with the lowest formal charges when all else is equal, like when both structures are satisfying the octet rule, or at least breaking the octet rule similarly, in that each atom, we just have one atom violating the octet rule in each one of these structures. So we go with the one where the formal charges are minimized as the better answer. And so notice if we went with a triple bond here, if we had a triple bond O with this structure here, where do I put the extra electron? I need to put the 11th electron somewhere. There's nowhere to add an extra electron without expanding octets of either the atoms. Likewise, if we went with a single bond here, we're not going to be able to satisfy the octet rule. That's 2, 4, 6, 8, 10 electrons. I could put one more electron in either atom, but then neither atom would be satisfying the octet rule. Both atoms would be deficient of an octet, so a single bond would not be the right answer either. So what we have to do is satisfy the octet rule for as many atoms as possible, and for NO, with an odd electron count, we can satisfy the octet rule for all but one atom, and then we choose the atom to violate the octet rule to give us the lowest possible formal charges. And then to throw one more example like we had done in class, for ClO, we can even do one more example for ClO minus. For ClO minus, we have 6 plus 7 plus 1, 14 electrons. So this will just be Cl single bond O, lone pairs all around, just like something like Cl2 or F2. Negative formal charge in the oxygen. For ClO, we have 7 plus 6, 13 electrons, so single bond, kick the electron off the O, give chlorine its octet, 0 formal charges all the way around. Okay, I hope this gives you a better idea of determining the Lewis structure for diatomic molecules. So one additional detail about ClO is I think mastering is actually looking for the wrong answer for this structure. So mastering is actually looking for a structure with a double bond. With that structure there. This one seems particularly bad to me because we're now expanding an octet unnecessarily for the chlorine atom and still violating the octet rule. So we could have had the octet rule not met for oxygen and the formal charge of chlorine 0, formal charge of oxygen 0. That seems like we're satisfying and minimizing the formal charges while breaking the octet rule. Here we are satisfying 0 formal charges still, but then expanding an octet. I mean, both seem, if the double bond is right, I'm not sure why the single bond is wrong. So I'm going to be emailing mastering about why they're not accepting at least both of these answers. But I think the one with the single bond is the one that you most likely arrive at and would believe to be the correct answer here. So I think you're being misled on a homework problem on mastering, and I wouldn't dwell too much on that particular problem. I would think the single bond answer is the one that should be accepting for full credit.